the vertical descent angle. Now the big question is, are there obstacles in the visual segment of the approach that could destabilize your approach in such a way that you'd have to maneuver to avoid them? If everything has worked out properly in the chart development department and the tree trimming department too, the answer to that question for the Fullerton approach is no. There are no obstacles that could destabilize your approach between the MDA and touchdown at Fullerton. Destabilize is the key word here. To be destabilized means that you'll have to maneuver your airplane to avoid the obstacles. Now, how do we know there are no destabilizing obstacles in the visual segment at Fullerton? Well, the presence of the VDA, the visual descent angle posted in the profile, is the clue. If obstacles in the visual segment could destabilize the approach, then the visual descent angle won't be published on that chart. Now, how's that for a good clue? This doesn't mean there are no obstacles in the visual segment. It only means that you won't have to maneuver to avoid them when entering the visual segment. Some approach charts will even tell you that there are obstacles in the visual segment, as shown on the RNAV GPS runway 26 approach to Nervino. The cautionary statement reads, visual segment obstacles. Notice that there is no VDA shown in the profile view of this approach. You don't need a clue to get a clue to use caution on the visual segment of the approach here. If you'd like to know where those obstacles are, take a look at the final approach segment in the plan view. Now that's a nice place to find an obstacle. Then again, since the visual segment is flown visually, you should be able to see and avoid the obstacle, especially since the required visibility for this approach is 1 1/4 statute miles. As a side note, there is a PAPI, Precision Approach Path Indicator, on runway 26. Keep in mind, however, that PAPIs only provide safe obstruction clearance 10 degrees either side of the runway centerline, and only for 3.4 nautical miles from the runway threshold. Now here is another thing you should understand about the visual segment and the visual descent angle on a non-precision instrument approach. On RNAV approaches, the presence of a gray sloped arrow, sometimes called a stipple, from the MDA to the runway symbol indicates that obstacles do not penetrate the 34-to-1 slope in the visual segment below the MDA. The gray arrow, the stipple, is shown here on the Meadows RNAV GPS runway 30 approach. This is an important clue that you can descend to touchdown using the VDA and remain obstacle-free. Obstacles below the 34-to-1 slope aren't a concern to you as long as you remain at or above the VDA. This is one instance where you can feel comfortable assuming your WAAS advisory vertical glide slope provides reliable obstruction clearance. Now, I say this tongue-in-cheek because the FAA only knows about the presence of new obstructions when they are recognized and reported through official channels. If Little Bobby builds a Saturn V rocket launching platform a half-mile from a runway's threshold and no one reports it, then you might find a nice addition to your landing gear upon touchdown. On the other hand, absence of the stipple, the gray shaded arrow on an RNAV approach, indicates that obstacles do penetrate the 34-to-1 slope on this RNAV approach. In this instance, the use of the advisory vertical glide slope shouldn't be expected to keep you clear of obstacles in the visual segment. And here is where your best obstacle avoidance tool is known as your EYE-BALLS, your eyeballs. Now, just to be clear here, we've talked about the VDA, the visual descent angle, as it applied to traditional and RNAV GPS non-precision approaches that involve leaving an MDA. Clearly, obstacles are not an issue on any visual descent angle or GPA glide path angle involving an RNAV approach flown to LPV or LNAV VNAV minimums. It turns out that WAAS-based approaches, those having either LPV, LNAV, VNAV, or LP minimums, can only be established if there are no obstacles penetrating the WAAS Qualification Surface, otherwise known as the WQS. The WQS is a slope beginning at the runway threshold and angled upward an amount equal to 2/3 of the glide path angle, the VDA. Therefore, when flying an approach having WAAS-based minimums, and assuming the HPL and VPL requirements are met, that would be the horizontal protection limits and the vertical protection limits of your WAAS equipment, then your glide path angle is always higher by at least 1/3 compared to the WAAS Qualification Surface angle. And this is why you can feel comfortable knowing that there are no threatening obstacles in the visual segment during the transition to landing when using LPV or LNAV VNAV minimums, as long as you remain at or above the glide path or VDA, vertical descent angle. That said, you must keep in mind above all else that the visual segment of any instrument approach is to be flown visually. And that means, regardless of the type of approach you are flying, RNAV or non-RNAV, you are responsible for avoiding obstacles in this segment, and you are given sufficient minimum visibility to do so, period. Assessing the potential of the visual segment of non-precision instrument approaches for obstacles is, well, a detective game. No VDP, no VDA, no stipple, visibility minimums of 1 mile or higher. Guess what, Colombo? There will be a greater potential for obstacles in the visual segment compared to an approach with one or more of these items, or compared to an approach having ILS or LPV minimums. And here's another clue for you. If an approach shows that some aspect of the approach, circling minimums for instance, is not allowed at night, then the possibility exists that there are unlit obstacles penetrating the 20-to-1 slope for any applicable circling runway. So act wisely in these instances and use your eyeballs accordingly. As a final note, there's nothing like local airport knowledge when it comes to flying an instrument approach to minimums or at night, or both. Approaching an unfamiliar airport without local geographical knowledge is where it's far better to avoid the circle-to-land option. Instead, you should opt for a straight-in approach to a runway having a vertical glide slope indicator and remain at MDA until you intercept the appropriate visual glide path. Of course, this isn't always possible, and that's where local airport knowledge can help keep you out of the trees or antennas when flying the visual segment of any approach. And as a final note, what type of instructor would I be if I didn't bring you the latest update in IFR chart design? So let's talk about a new kid on the block known as the VGS, or Vertical Guidance Surface. It turns out that the FAA so liked the idea of the WAAS Qualification Surface that, as of October 17, 2017, it decided to apply a similar protection principle to all precision approaches, approaches with vertical guidance, and straight-in non-precision approaches. As of this date, all approaches, new and old, will eventually be evaluated so they meet VGS criteria. Now I'm talking about something known as the Vertical Guidance Surface. Here's how this surface works. When completed, there should be no obstacles penetrating a slope that's equal to 2/3 of the published glide path angle. Essentially, the vertical guidance surface is an obstacle clearance slope angled upward from the runway threshold at an angle 2/3 of the published glide path angle, the GPA, and begins at the threshold crossing height for all TCHs between 40 and 50 feet, and the starting point will be adjusted slightly outward away from the threshold for TCHs of different heights. It's not much though. The vertical guidance surface extends outward and upward until reaching the highest published decision altitude for a precision approach or an approach with vertical guidance, or until reaching the horizontal position of the VDP visual descent point for the highest published MDA for a non-precision approach. Now, should any obstacle penetrate the vertical guidance surface, either the glide path angle will be adjusted, the procedure turn completion altitude will be raised, or the final approach course will be offset so the penetrating obstacle is no longer an issue. The vertical guidance surface, when eventually applied to all approaches, will give you greater confidence that obstacles will not destabilize your airplane in the visual segment of the approach. So expect to see more gray stipples identifying the visual segment of the approach, as well as approach minimums possibly being reduced to less than 1 mile flight visibility. These are all the signs that the visual segment of the approach is more likely to be free of destabilizing obstacles.